score on this computer. All right, so for this problem, if you look at it, it says example of finding the area under any normal curve. So tell me an IQ score can be modeled by a normal distribution with a mean of 100 and a standard deviation of 15. Find the probability of an individual having an IQ score greater than 120. All right, so if you look at it, I already gave you the mu is 100. And I already gave you the standard deviation, which is 15. So all of that is given to you. I'm also telling you what I want you to find the probability for. I want you to find the probability for an IQ score greater than 120. So since we want to find the probability that somebody has an IQ score greater than 120, 120 will be my X variable. All right, so far we have mu equal to 100, we have sigma equal to 15, and we have X, which is equal to 120. Any questions so far for any of those three notation? All right. So let's go to it. All right. So first thing you kind of want to go ahead and do and make a drawing. So here go my drawing. So we're gonna put the mean in the middle, which is 100. Now we're gonna put 120. So 120 should be to the right of 100 because 120 is bigger than 100. And if you look right here, the keyword that tell me which part to shade is greater than. So tell me we want IQ score that is greater than 120. So we want like IQ score like 130, 140. So that means all of the probability to the right hand side. All right. So far, everybody good with this drawing? All right, everybody good with the drawing. So up next, we're gonna go ahead and go ahead and just make some notation. So this notation, you're gonna be for once we actually go to our TI-83 or 84, for we know what to enter. So the calculator gonna ask us for the lower. They're gonna ask us for the upper. They're gonna ask us for what is our mu. And it's also gonna ask us for our sigma. So for this one, we should just know mu and sigma. Well, mu and sigma is already given to us. They tell us is 100, and they tell us is 15. So we'll put 115. So for the lower is whatever the lowest value that's shaded. So if you look at it, it get cut off right here. So this is the lower half. So the lowest value that we have is 120. If you look at the highest value that we have, well, it keeps going. So since it keep on going to the right-hand side, technically it's going to positive infinity. So since your calculator doesn't have a button for positive infinity, where you put 10 to the 10 power, where you're gonna put a very big number to represent positive infinity. Any question in regard to that so far? All right, so up next, we're gonna go ahead and we're gonna go ahead and just go to the calculator. So let me share my calculator. All right, so let me turn it on. Turn on. All right. So if you kind of look, you want to hit the second button. So you want to hit the blue button all the way on top. And you know that you hit the second button because now I have the arrow pointing up. So now you want to press the VARS. And then if you look at number 2, it says normal CDF. And if you look at it, it's asking us for the lower. So the lower is 120. So let's put 120. If you look at the upper is just 10 to the 10 power. If you look at my mu is 100. If you look at standard deviation is 15. If you go to paste, press enter, and that's your answer. So we get probability that x is greater than 120 is equal to 0.0912. Any question on how we got the answer from the calculator? Okay, so I'm gonna transition back to my notes. All right, so we'll transition back to my notes. So if you look right there, I have probability of x. Well, let me highlight it for you in case you're wondering, what am I talking about? If you look right there, we have probability of x is greater than 120 is equal to 0.0912. All right, and that's it on how to find the probability. Any question on how we found that probability? All right. So you also want to know, what does that probability signify? So just remember, probability is percent. So I mean per the 100. So let's do this follow-up question. So it says, if 100 individuals are randomly selected, how many should we expect to have an IQ score greater than 120? So it's saying we have 100 individuals. So it's saying if we have 100 individuals, how many of these 100 individuals should we expect to have an IQ score greater than 120? So to figure that out, all you have to do is multiply how many people we have and multiply that by the percentage of people who should have an IQ score greater than 120. There you go, 0.0912. If you multiply those two values, you get 9.12. So roughly, we should have 9 people. So we'll say, if there's a room of 100 people, we should expect 9 people to have an IQ score greater than 120. And that's it for that problem. Any question in regard to the last problem? All right, so let's scroll on down. So for this one's an example of finding the area under any normal curve. A lifetime of a certain brand of tire is approximately normally distributed with a mean of 42,500 miles with a standard deviation of 3,200. All right, so first thing you want to just go ahead and do, you want to extract some of the information that's given to you in that opening passage. So one thing that's given to you is the mean. So they told me the mean is equal to 42,500. The next thing they're given to me is standard deviation, which is 3,200. All right. So they give me those two information, but more importantly, the most important thing that they give us, they tell us is a normal, well, that is normally distributed. Because if we don't know we have a normal distribution, you can't really find the probability of this. Because if the data set is skewed to the left or skewed to the right, then pretty much our data set, you can't find that probability, because this only works if our data set is normally distributed. So we know mu is equal to 42,500. We know sigma is 3,200, and we know it's normally distributed. All right. Any question in regard to that so far? All right, so let's do part A. So let's go ahead and draw this out. All right. So if you look at part A, it says if we randomly select one tire, what is the probability that tire lasts over 45,000 miles? So first thing we're gonna go ahead and do, we're gonna go ahead and place the mu. All right. So if you look at 45,000 is bigger than 42,500. So that means you put 45,000 to the right of mu. So we'll put 45,000. And if you look at it, we want it to last over 45,000. So we shade the right-hand side because we want it to last over 45,000. Everybody good so far on 42,500 in the middle and the 45,000 to the right of the 42,500. All right. So just to kind of make this easy for once we go to the calculator, we're going to set up the lower, the upper, mu, and sigma. So mu should be 42,500. Sigma should be 3,200. My lower, if you look at the lower, it get cut off at 45,500. So this will be my lower. So yeah, 45,000. If you look at my upper, where the upper, there is no cutoff to it. It keeps going and going to the right-hand side. So that means that's going to positive infinity. But remember, we don't have a button for positive infinity, so we put 10 to the 10 power. All right. Everybody good so far on my lower, my upper, my mu, and sigma? All right. So what I'm going to go ahead and do right now, I'm going to go ahead and transition over to the calculator to get the answer for the. All right. So first thing you want to do, turn it on. So once again, I'm going to go second, bars. I'm going to go to normal CDF. I'm going to go ahead and just enter all of the information we have. So the first one is 45,000. The upper is 10 to the 10 power. So we'll just leave that as is. So then we put 42,500. And sigma is 3,200. We go to paste. We go to enter. And that's our probability. So we get probability that X is greater than 45,500 is equal to 0.2173. Any question in regard to how I got 0.2173 from the calculator? Okay, so I'm going to go ahead and transition back to my notes. All right, so that's it for A. So let's go ahead and let's do B. So if you look at B, B says if we randomly select one tire, what is the probability that the tire lasts under 37,675 miles? So let's go ahead and draw this normal distribution. So in the middle, we'll put 42,500. If you look at it, we want it to last under 37,675. So 37,675 is smaller than 42,500. So we put that to the left. So we'll say 37,675. if you look at it, we want it to last under 37,675. So that means the number should be below it. So that means you shade the left-hand side. So far, any question on why I shaded the left-hand side? All right. So let me go ahead and do all of this. Oh, let me save some time. Let me copy and paste. So first thing we're gonna go ahead and find, we're gonna find the lower. So the lower is over here to the left-hand side. If you look at the lower doesn't have a cutoff. So since the lower doesn't have a cutoff, we're gonna say the lower is just negative infinity. Because you keep on going to the left-hand side. But just from your calculator, it doesn't have a negative infinity, so you put negative 10 to the 10 power. If you look at the highest cutoff that we have, well, the upper will be here. So that's my upper. So the upper cutoff will be 37,675. So that's what we put for the upper. So let's say 37,675. And then the mu and the sigma, since it's coming from the same problem, it stays the same. Any questions so far? We got the lower or the upper. All right, so let me go ahead and share the TI-83. So first I'm gonna do, I'm gonna put second, and then you're gonna put VARS. You're gonna go down where it says normal CDF. So if you look at it, all of my old information is still there. So for mu and sigma, I don't have to change it. The only thing I have to change is my lower bound and my upper bound. So for lower, we're gonna put negative infinity. So we're gonna put negative 10. So we're gonna put negative 10, and then we're gonna put it to the 10 power. So that's my lower. So my lower will be negative 10 to the 10 power. My upper will be 37,675. So 37,675. And then mu and sigma will all stay the same. We go to paste. And that's your answer. So say probability that a tire would last less than 37,675 miles. The probability of that occurring is pretty much 6.6%. All right, and that will be it for part B. Any question in regard to part B? All right, so let's do the last problem of these, and then we'll do something else. All right, so the next one is example of finding the area under any normal curve. So it says a machine that cut cork with wine bottle operate in such a way that the distribution of the diameter of the cork produced is well approximated by a normal distribution, with a mean of 3 centimeter and a standard deviation of 0.15 centimeter. The specification called for cork with a diameter between 2.92 and 3.17 centimeter. A cork not meeting these specifications is considered defective. A cork that is too small leak and cause the wine to deteriorate. A cork that is too large doesn't fit in the bottle. What proportion of cork produced by the machine are defective? All right, so let's go ahead and let's get some of the basic information they gave us. So the basic information that they gave us that the mean is 3 centimeter. They gave us that the standard deviation is 0.14 centimeter. They also told us that the distribution is a normal distribution. All right. So what we kind of want to go ahead and do now is see what is it that they want to find. So if you look at the last sentence, you want to know what proportion of cork produced by this machine are defective. So they already told us what do they consider a defective cork, a cork to be. Anything bigger than 3.17 diameter or anything below 2.17, well, 2.92 is considered defective. Because if it's too small, pretty much the cork wouldn't pretty much stop anything, or if it's too big, they can't cork the wine. So let's go ahead and draw this. So the 3 go in the middle because that's the mean. All right, so then we have 2.92. And then we have 3.17. So if it's greater than 3.17, the machine will be considered defective. If it's smaller than 2.92, the cork will be considered defective. So that's the probability that we want to find. So we want to find the probability that the cork is defective. So we want to find the area of the blue. But the thing is, you really don't want to do that because you kind of want to use the complement rule for this. Because what you want to do, you want to find the probability that the cork is not defective. Let's see. So we want to find the probability that the cork is not defective because that's going to be easier. Because if I find this probability and then find this probability, I'm going to have to add those two probabilities. So I'm going to have to do the normal CDF twice because I have to do the normal CDF for the left tail. And then once again, I have to do the normal CDF for the right tail. But what I could do, I could find the probability of the middle, which is telling us how many cork are not defective. And then you do the complement of that, and that will tell me how many cork are defective. So we're gonna go ahead and do that approach. Any question in regard to that so far? Alrighty. So first thing we're gonna go ahead and do is figure out what is the lower, what is the upper, what is our mu, what is our sigma. So for mu is 3, because we already said mu is 3 centimeter, and our sigma is 0.15. All right. So in this case scenario, what would be my lower? So if you want, you could put it in the chat, or if you want, you could shout it out. Cool. 2.92, perfect. Thank you, Amanda. So put 2.92. For this one, what would be my upper? Cool, thank you, Cesar. So 3.17. All right. So we're gonna go ahead and just find this. So remember, once we find this probability, this is the probability of the cork being not defective. We want to find the probability of it being defective, so we do want to, at the end, take the complement of whatever probability we find. So up next, let me share my TI-83 or 84. So we'll turn it on. So we'll say second VARS. We'll do normal CDF. So for my lower, we'll put 2.92. For my upper, we'll put 3.17. For my mu, we'll put 3. For sigma, we'll put 0.15. All right, so we'll go ahead and paste. All right. So say 0.5. So that's not the technical way to find it, to write it, Amanda. For this one, what you want to do, you want to say is, well, 2.92 is less than x, which is less than 3.17. Actually, so you just messed up on the last inequality. I'll transfer it over for the notes. So here's a technical way that you want to write it. Because you can't say greater than, okay, you can't say x is greater than 3.17 because that means you shade the right hand side. So you want to say it's between those two values. So you say less, well, you say 2.92 is less than x and x is less than 3.17. All right. So just remember, this is the probability that the quark is not defective. We want to find the probability that the quark is defective. So to find the probability, oops, don't want to use a highlighter. You find the probability the quark is defective. You want to do 1 minus the probability it's not defective. And let's see, what do we get? So we'll say 1 minus 0.5746. Then you get 0.4254. All right, so that's our final answer. So the probability that we get a quark that is either too small or too big is 0.4254 or 42.54%. And that's it for that last problem. Any question for that last problem? All right, so let's move on. All right. So far, let's kind of just recap what we just did. So right now we had an x value and we wanted to go ahead and find the probability of that x value occurring. So what we're gonna do right now, we're gonna do the opposite. So right now, we're gonna start off with a percentage. And what we wanna do, we wanna convert that percentage into a x value. So for this one, it could be different because it's not going to ask you to find the probability because they're actually going to give you the probability of that event occurring, but they're not going to give you the x value. So what we have to do, we're going to have to find the x value. So that's what we're going to be working on next. All right. So one thing, so we're going to use the inverse norm for this portion. Whenever you're using the inverse norm, it always want it in this notation. It wants the area, then it's going to want the mean, and then it's going to want standard deviation. So for inverse norm, it always wants the area to the left. So we want area to the left. If you give it the area to the right-hand side, it's going to give you the complete wrong answer. So I'll kind of show you what I mean by that for this next example, but you kind of keep a note that it always wants the area to the left. So we're going to go ahead and do this very basic problem. So for this problem, they tell us mu is equal to 35, sigma is equal to 5. And if you look at A, it says find the x value for the bottom 25%. So let's go ahead and draw this out first. All right. So you always want to go ahead and just put the mean. So the mean is 35, so you put the mean pretty much in the middle. Up next, if you look at it, we want to do the bottom 25%. So the bottom 25% will be this area over here. Because they say bottom, bottom usually means left tail. And this is the left tail. Or you think about it as bottom. So this is our bottom 25%. So what we want to do, we want to find the X value that correspond to that cutoff. Because we want to know what is the X value that cut off the bottom 25% from the top 75%. Because that's pretty much what we're doing. We have the bottom 25%, which is the bottom 25%, but it's also cutting off the top 75%. So we have to see what is the X value that caused this separation. So one thing that you should already kind of notice, since the X value is to the left of 35, we should be expecting a number smaller than 35. If you get a number bigger than 35, well, you did something wrong, because since we placed X on the left-hand side, we should be expecting a number lower than 35. Okay. Everybody good so far with that? All right, so let's get to it. So first thing we're gonna do, we're gonna figure out what is the area. So the area is the area to the left. So if you look at it from where we have the X value to the probability of the left, we want the probability of the left to be 0.25. Because that's the area to the left-hand side, 0.25. You also want to tell it what the mu is. So mu is 35. Sigma is equal to 5. Any questions so far? I got area 0.25, mu is equal to 35, and sigma is equal to 5. All right, so I'm gonna go ahead and transition over to the TI-83 so that way you can see how to enter it in. All right, so first thing you wanna go ahead and do, you wanna hit the second button. So hit second, hit VARS. And then if you look right here where it says inverse norm, you wanna select that one. So first thing it asks you is ask you for the area. So you put 0.25. Next thing it asks you is the mean, which is 35. Last thing is sigma, which is 5. So let me go to paste. And if you look at it, it's 0.25, which is the area. Then it wants the mean, which is 35. And then it wants sigma, which is 5. Everybody good so far on how to enter that into inverse norm? All right, so then you press enter. And we get X is equal to 31.63. And that'll be it for part A. Any question in regard to part A? So let me switch over back to so up next we're going to do part B. So if you look at part B, it says find the X value for the top 25%. So if you look at A and B, both of them want the same percentage. They want 25%. The only thing different from A and B, one of them want the bottom 25%, the other one want the top 25%. So let's do B. So for B, we're going to draw this out. We'll put 35 in the middle. Since this is the top, you want to shade this portion in. And we're going to say this is approximately 25%. So what we want to do, we want to find what is the X value that's breaking up this top 25% from the bottom percentage. Any question for the picture? Okay. So if you remember from the beginning of this portion, well, of this topic, I went like when the TI-83 or 84 want the area, it always want the area to the left of it. Because if you put 0.25 as your area, it's going to give you the answer that you get in part A, which will be the wrong answer. Because if you get 31.63, you go 31.63 is over here. That's not the top 25%. In order for you to tell it that you want the top 25%, you just pretty much have to take the complement rule, because you should know the area underneath the curve is 100% or 1. So if this is the top 25%, that means this is the bottom 75%. And this is the area that we're going to use for the TI-83, because the calculator always wants the probability to the left of it, not the probability to the right of it. So let's go ahead and figure out the input. So we're going to say inverse NOR, and we'll say area, we'll say mu, and we'll say sigma. So for this one, the area, we're going to tell it we want the area of 0.75 because we want the probability of the left-hand side. So we put 0.75. If you look at the mu is still going to be 35, and sigma is still going to be 5. So we're going to say area is equal to 0.75, mu is equal to 35, sigma is equal to 5. Right. Any questions so far for those 3 inputs? All right, so let me go ahead and transition over to the TI-83 so that way you can see how I input the information. All right, so the cool thing about the TI-83, if you want to re-enter this, what you could do, you can hit the second button and you can press enter, and it'll give you exact same equation that you did for the last time, well, from the past history. So I could go here, change the area to just 0.75, and I'm done. So we get X is equal to 38.37. And that would be considered the top 25%. So 38.37 is breaking up the top 25% from the bottom 75%. And that's it for part B. Any question in regard to part B? All right, so let's actually do some word problem about this. So it says a lifetime of a certain brand of tire is approximately normally distributed with a mean of 42,500 miles with a standard deviation of 3,200 miles. So we're doing the tire problem again. So we have mu equal to 42,500. Sigma is equal to 3,200. So if you look at the question, it says, what warranty should the company use if they want 88% of the tire to outlast the warranty? So if you kind of notice for this one, it's not asking us for probability or to find the probability of anything. It's telling us, hey, we want 88% of the tire to outlast the warranty. So they're telling us we already know the percentage that we want, but we kind of have to figure out what is the mileage, or how many miles should we say, or should we guarantee this tire to last before pretty much it run out of the warranty. So we want 88% of the tire to pretty much last that long. So that's why we're gonna just get the percentage, and we're gonna convert this into an X value. So let me go ahead and draw this out. So the middle will be 42,500. So for this one, we want 88% of the tire to outlast the warranty. So we kind of want to make it where it lasts more than the average, because if it lasts more, because, well, kind of thinking about it, if a tire lasts 42,500, well, that means 50% lasted that long, but also mean that 50% pretty much was under that value. So you don't want to say exactly the mean, because that would be a 50-50 split. We want 80% of the tire to outlast the warranty. So that means it should be over here. And this will be the 88%. Because we want 88% of the tire, so we want this percentage over here to be that 88%. So if you kind of think about it, we want 88% of the tire to outlast the warranty, or what? No. Yeah, so we want 88% of the tire to either last that long, or whatever. No, yeah, that's wrong. Oof. There you go, Minecraft. So, yeah, sorry about that. So we actually want that 88% because we want all of these tire to last longer than the warranty. So to last longer than the warranty. So we want that 88% to last longer than the warranty. So that means we only want 12% of the tire to actually have to use the warranty. So what we want to do, we want to figure out how low should we set the warranty, so that way 88% of the tire will actually outlast that warranty that we give them. So that's what we're going to do. Any questions so far for the drawing? Let's go ahead and do the area, the mu, and the sigma. All right. So the area will be the point 12. Mu will be 42,500. Sigma will be 3,200. Right, so I'm going to go ahead and put that into my calculator. So I'm going to transition over to my calculator. So I'll turn it on. So we'll say second, bars, inverse norm, area will be 0.12. Mu will be 42,500. And lastly, sigma will be 3,200. So if you go to paste, press enter, and we get 38,740.04. All right, so this is what they should set their warranty at. Because if they set their warranty at this value, if the mean is 42,500, that means that most tire or 88% of the tires should last way longer than this amount of mileage. So if they set the warranty as this is kind of telling us that only 12% of the tire will last less than this. So that means they only have to repair or return or give back money to tires that go less than 38,740 mileage or miles. All right. But that's it for that problem. Any question in regard to the last problem? All right. All right. So we're gonna go ahead and do this last problem, and there's more problems for that way you can get practice on it. But I think with this last problem, it should be good enough for practice. So for this one, it says the resting heart rate of a healthy adult horse average 46 heartbeat per minute with a standard deviation of 8 beat per minute. A horse whose resting heart rate is in the upper 10% of the distribution of heart rate may have a secondary infection or illness that need to be treated. How fast must a healthy horse heart be beating to fall into this at-risk group? All right, so first thing we're gonna go ahead and do, find the mean. So the mean is 46 heartbeat. Our standard deviation is equal to 8 beat per minute. We're gonna go ahead and draw this out. So we get 46 right here. And if you look at it, we want 10%. So, or sorry, we want the upper 10%. So that means this side over here. So we want this to be 10%. And we want to find this X value. So just remember, the TI-83 always want the area to the left. So if we want the top 10% or the upper 10%, in our calculator, we have to give it the bottom percentage. So we want to give it 90%. Because if you go 10% plus the 90%, should give you 100%. Everybody good so far with the drawing? All right, so let's do the area. So the area will be 0.90. My mean will be 46. And lastly, standard deviation will be 8 heartbeat per minute. Any question on how we got 0.90, 46, and 8 for area, mu, and sigma? All right, so let me go ahead and transition over to the TI-83, or TI-84. And let's go ahead and do this. So we'll press second, vars, inverse norm. So we'll put area at 0.90, or you could put 0.9 because it's exactly the same thing. You could put mu, which is 46. You could put standard deviation, which is 8. Press paste. And you get X is equal to 56 point, let's say 25. So if a healthy horse has a heartbeat above or equal to 56.25, that's when we that's when they should be worried that the horse might have a secondary infection or illness that need to be treated. But that's it for the last problem for getting an x value. Oh, sorry, getting a percentage and converting it into an x value. Any question in regards to this last problem?